All right, welcome to soils. We are like digging in the mud and the dirt. This is Properties of Soils 4.3. So we know that soil is important for everything. I've talked about this in the previous video about the soil formation, but us humans would not be here without soil because soil has to be fertile in order to provide the nutrients in order for all plants, all of our producers, all of our terrestrial producers to grow. Without that soil, we have no terrestrial producers, and therefore we have no primary consumers, and therefore we have no humans. So extremely important that we have fertile soil around the world. All right, some things that are super important. In order for soil to work, for it to be fertile, it needs to be able to retain water for plants. And very important, these pores, I'm trying to point to it, I can't point to it. These pores in here need to be able to have water flowing through it, and the soil needs to hold the water so that these plants can grow. The only source of water for our plants is the roots. Second, we need to be able to drain excess water away. If we have too much water, then we can get rot that's happening in there. And that bacteria and the rot, and all of a sudden our plants can't grow. And then last, we have to have sufficient aeration. That aeration does two things. It provides oxygen, which is needed in those roots for respiration, and it also gives space for the roots to grow. So, and also we need our microbes, our nitrogen-fixing bacteria. All of that needs to be in that soil down below so that the plants can grow. Okay, first thing we need in order to have good soil is porosity. This porosity is these pores which are between the particles here. So these are all minerals here, and then in between those minerals are what we have these open spaces called pores. These pores are so important because they allow oxygen to move through, they allow water to move through, and then when that water moves through, it's going to bring nitrates and phosphates with it, and it also allows our roots to move through as well, allowing those roots of the plants to get larger and larger and larger and larger. So, super important, those pores. We need to have enough pores. Second is permeability, which is the ability of water or any liquid to move through those pore spaces. As I mentioned, water is important because it brings nitrates and it brings phosphates. And so soil with low permeability, it's not going to drain well, and it's going to become waterlogged, which is where that bacteria comes in, and we have issues. However, if we have high permeability, it could drain too quickly. And as I mentioned, those nitrates, those phosphates, they move with the water. So if the water leaves, so do those nitrates and those phosphates. So this permeability needs to be just right in order for successful soil. Now, keeping in mind that porosity and permeability are most important when it comes to soil, there are some things that humans can do to reduce that porosity and the permeability. And that biggest thing is the compaction. We can compact the soil, and when we do that, we reduce those pores and we reduce the permeability of a soil. And as we know, without pores, our water can't get through, nutrients can't get through, air can't get through, and if air is not coming through, then we can suffocate our plants with too much water. And then it becomes very difficult for our roots to penetrate through that soil and grow. So how does this happen, Ms. Clark? When does compaction happen? So unfortunately, it happens a lot with agricultural processes. When our soil is dry, there's air between those particles. We have pores. And so we can drive on top of it. It's not a big deal. But the problem comes when it's wet. And when it's wet, it's going to compact more. We're going to squeeze that water out. And when we drive very, very heavy farm equipment on top of that soil, When it's wet, it's going to compact together. This also happens when we take cattle. And cattle walk over and over and over again on this wet soil. It's also going to lead to compaction. Now, the other way this happens is through a process called tilling. Tilling the soil kind of like stirs it up and moves it around, and we do that to get rid of the weeds. However, the issue is that when we do that, we're also going to have more compaction. So just a reminder one more time, we've talked about, I think, this over and over again, that plants need the air for respiration. They need access to that oxygen for respiration. So our normal soil has tons of pores in it. Now our compacted soil here, there's no oxygen, there's no water getting through this. So it often causes our soil to become quite waterlogged, and the roots are going to drown. Okay, so now we're going to talk about some of the main components of soil. These are the important ones that you need to know for the AP exam and for this class. 3 main components of soil. We have sand, we have silt, and we have clay. Sand is the largest at about 2 millimeters. Silt, smaller than that. It's a version of sand. And then clay. Clay is so super tiny, less than 0.0002 millimeters. Tiny, tiny little particles. Okay, we've briefly talked about this already, but let's just review one more time. Sand is made of quartz. Quartz is silicon dioxide. It's a chemical compound and is very resistant to chemical weathering. It's the same thing that glass is made out of, so very resistant to any chemicals that come through that could potentially break it apart. Good things about sand, about our sandy soils. It's going to reduce that compaction. Because they're already large molecules, it's very hard to compact them, and they don't really absorb water very well. So again, we're not going to have a lot of compaction that happens. They do, however, they improve drainage, and that's because they're so big and they don't absorb water. So if we're struggling with a plant that's being suffocated by water, we can add some sand into it, and that will allow more drainage to happen. Now, unfortunately, disadvantages of this is that it does not retain water very well. And so because of that, the nutrients go with that water. So it does not retain those nutrients very well. If you think of visions of sand dunes, you rarely see plants on those sand dunes because they're not getting the nutrients or the water that they need. All right, silt is a version of sand. It's a much smaller, it's also made of this quartz, the silicon dioxide, but much smaller. And because of its tiny size, water will adhere to it. And because we have lots of little bitty ones, there's a lot more surface area for that water to adhere to. So it can retain water, which is great. And as we know, when it retains water, it's also retaining the nutrients that flow with water. One example where we love flooding is the Nile River. The Nile River has a lot of silt in the bottom of it. And so when that river kind of is flooding and kicks up all that silt and then floods into the farmlands, it's really good because that silt is bringing the nutrients with it and the water with it. So the Nile River, often whenever it floods, the farmers are very excited because of the nutrients it's bringing to those farmlands. Now, disadvantage, this should say silty soil. Sorry, not sandy soil. But it doesn't drain well. It does hold on to that water, so therefore it really doesn't drain very well. And unfortunately, because they're smaller pieces, they also compact super easily, which is also a disadvantage. And then finally, we have clay. Clay is produced when the rock material has been chemically weathered down. Rain has acid in it because of the carbon dioxide, so we have carbonic acid in the rain already. And when it hits rocks, it's going to release these feldspars and these biotite from the rocks and slowly kind of chemically weather them down. And that's how we get clay. Clay are these very flat pieces, And because of that, they retain water. They have a negative charge to them, and they're going to retain water, and they're going to retain a lot of nutrients, which is fantastic for clay. So it's great because that water is going to attach to it. And so it brings a lot of water with it. Whenever we have a lot of clay in the soil, it's very, very wet. Disadvantages are, again, it's wet and it's actually an impermeable substance. There's a lot of lakes that they're like, how do we prevent infiltration? Well, what they do is they line the bottom of the lake with clay because it is completely impermeable. Water is not moving through that clay. So it drains very poorly. It also compacts because instead of having rounder pieces, I've got flat, and they line up and they'll compact really nicely. So easy to compact, and it drains very poorly, which are big issues. Okay, so now let's look at this. So you can see sand, a lot more pores in that sand. Our silt, much, much smaller, so super tiny. So not as many pores there. And then look at this, there's like nothing. Because these flat particles of clay line up against each other, tiny, like if there's no pores really at all. So water and air is not moving through that, unfortunately. Yeah, that is just completely impermeable for water. Okay, let's talk about loam. Loam it's a type of soil that is often commercially used now because it's a mixture of sand, silt, and clay. And they found a way to make it perfect, like the perfect soil content of the mixture of everything so that we can use it for the right purpose. Loamy soils are perfect for agricultural purposes. They've got 40% sand, 40% silt, and 20% clay. So you can see that aeration, sand is good for aeration, clay is poor. Loam is perfect. Same with drainage. For drainage, the sandy is great for drainage, clay is horrible. Loam is perfect. But then also for nutrient capacity. Sand is very low, clay is very high, loam is perfect. It's right in the middle. So it's a great in between the sandy soil and our clay soil. Okay, so the way that we're going to look at soil in class is by measuring the percent of these three components: clay, silt, and sand. So we're going to look at the combination of all three of those. This is called a soil texture triangle. And by looking at the percentage of each of those three items, we can figure out, is the soil more clay-like? Is it more sandy loam? Is it more silty? Is it more silty clay loam? Kind of what combinations identify what this soil is like. Okay, so let me show you how we're going to do this. We're going to get some percentages. So here's an example. We have 15% sand, 60% silt, 25% clay. We're going to draw a line for each of the components that's parallel to the zero. I'll show you what that means real second. And then we're going to see where they all come together. So let's start with our 15% sand. So we're going to find sand on the bottom here. Here's our sand on the bottom. And we're going to find our zero. Here's our zero line right here for sand. That's our zero line. Our number is 15%. So we're going to go 15, and then we're going to draw that line parallel. Parallel to our zero line. So here's 15. I'm going to draw it parallel to our zero. Great. So there's our sand done. Now let's find silt. So here's my zero line for silt right here. So now I'm going to go to 60% and draw another parallel line at 60%. So already I'm going to be crossing right here, but let's do the clay just to check and make sure. So my clay, I'm 25% clay. Here's my zero line for clay down here. So I'm going to go up to 25% and draw my draw my 25% line parallel to that 0 line. That's the most important part, is that we have to draw it parallel to the 0. We're going to practice in class. Don't worry. So based on that, I find that I have a silty clay loam. That is our type of soil. We're going to practice this because you will need to do this on the AP exam. All right, last thing I want to talk about real fast is that we have talked about compaction. We've talked about issues. One of the last issue we need to talk about is erosion. Erosion can happen by wind. It can also happen by water. So erosion is when our wind or our water picks up this dry, loose soil and it takes it away. Most of the time, it's going to carry clay and it's going to carry silt. Hey, come on in. I'll stop my video real fast.
Are you making an AP video?
I am. So because that clay and the silt are lighter than our sand, they're going to be taken away first. And as we know, when the clay leaves and the silt leaves, there's nothing that can retain moisture left at all. So therefore, our soil can't retain moisture, can't retain nutrients. It's not going to grow plants. Ways we can fix this. This is a gorgeous example here. We can introduce these windbreaks. So these are a bunch of trees that they're putting around each of their, I don't know, call them a farm quarter or plot maybe. And by having those trees there, there's a lot less wind erosion because the wind isn't sweeping across the whole field. The wind is kind of broken by those trees. And then finally, the other thing that can happen is we can have rain or water that carries away soil components. So this is a great example here. You can see how water has come through, whether it's a flood or whether it's a heavy rainstorm. And the water kind of creates these crevices here. We have these agricultural processes that are leaving this topsoil exposed because they probably are not watering it. So when it's super dry like that, that is when water can come through and erode it. It's going to carry away all of that topsoil. And when it does, it's leaving behind not much. So plants cannot grow after that topsoil is taken away. Now, a way to break this apart. So this is a hillside here. As we know, here, let me move my face. As we know, water flows down the hill. So by creating these contours, these plowing of these contours, it means that water gets stopped along the way. If water's flowing down, it's going to get stuck here and then stuck here again and stuck there again. So we're not going to get these crevices here like shown in this photo as well. So this contour plowing helps reduce that. So two things, contour plowing and putting up our windbreaks with the trees. Two things that can help this erosion and to protect our soil. All right, that's a wrap. Thanks, guys.